Now here we have the second case. This is a cantilever beam subjected to a uniformly distributed load. Here you can see the load he is telling us how much W per unit length. Okay. Now if I am having 10 newtons per meter, if it is there, let us say this is how much? 10 newtons. Understand? I have 10 newtons here. This, what is this distance? This distance is 1 meter. If I have another 10 newtons over here, so this is also, let us say, 1 meter. So what will be the total weight? Total weight will be 20 newtons, is it not? Because you have 2 meters length is there. Okay. Where usually we assume the weight to act, we assume the weight to act through the center of gravity, like this. Okay. For this 2 meter, 1 meter is the center of gravity. Fine. So now let us just try to draw the bending moment and shear force diagram for them. Let me just delete this. As usual, what is the first step? First step is to write the sign convention. Where is the sign convention? First write like this. X, X, right side downward is what? Positive. Left side upward is positive. Okay. And then left side downward is negative. On the right side upward is negative. And then bending moment is obviously like this. Downward bending moments are negative. Upward bending moments are positive. This is bending moment, is it not? Okay, that's fine. So now let's go. So what we will do now, let's try to find out shear force at what point? Shear force at A. Shear force at A. Here I will not write between A and B. Understand? The reason is that it is a uniformly distributed load. As you come from the left side, just if you move towards the right, so what is happening to the weight over here? Weight is keeping on increasing, is it not? Weight is keeping on increasing. So you just can't just say between A and B. It is not a constant value. Okay. It is keeping on changing. Okay. At any point, if I want to, let us say, if I write somewhere over here, somewhere, some line over here like this, if I just put a line like this somewhere over here, XX. If I put XX on the left side, you see shear force at XX is what? On the left side, you can see that it is W per unit length. If this length is X, if this length is X, then what will happen? Shear force at XX will be how much? Whatever is the force on the left side, it is how much? W multiplied by length is how much? X, is it not? WX. Okay. When X is equal to 0, what will happen to the shear force? Shear force is 0. That is point A, is it not? When X becomes is equal to L, what will be the shear force? Shear force will be is equal to minus W into L. Correct? Because left side downward is negative. Okay. So that's what he is doing over here. See, at point A, shear force is 0. As you go at point B, shear force became minus WL. Is this clear? It is negative because we have followed the sign convention. This is your shear force diagram. So the line is what? The line is a straight line. See, this is a straight line. Correct. Why it is straight line? Because here the power is 1. Here the power is 1. Okay. Now let us go to bending moment diagram. So now bending moment diagram is what? Let me change the color just for the sake of clarity. Now bending moment at XX. Okay. Bending moment at X. X. What is the value of bending moment at XX? At this point, at this line, you have the weight. Where is the weight supposed to act? The weight is supposed to act through the middle point, is it not? The weight is supposed to act through the middle point. Let me just delete because it is jumbling up over here. Okay, just to show you neatly, I'm just deleting this one. Right. So now I'm going back here. So where this weight W into X is acting, we believe that it is acting through the middle point, is it not? W X. What is this distance? X divided by 2. Because this we have said it is X, is it not? So it is trying to bend the beam downward like this. So it is minus Wx multiplied by X by 2. Okay. This becomes how much? Minus W x square by 2. See here what you have? You have what? Square. So it should be a parabolic curve. Understand? So when x becomes 0, what will happen to bending moment? Bending moment becomes 0. See? It became 0. When x becomes equal to L, when the value of x is equal to L, what will happen to bending moment? Bending moment is equal to minus W L square by 2. Do you see here, since it is a square, it is a parabolic curve. It is a parabolic curve. Okay. Since it is trying to bend the complete beam down like this, so we have got a negative sign. We have got a negative sign.